All right, before I get started, I do want to make a few reminders. Number one, let's go to the calendar. All right, so let's just go to the calendar over here. All right, so you should be seeing calendar. And I just want to remind you that today is December 1st. Okay, so today we're just going to do a wrap-up. I haven't updated this. A summary wrap-up of the course. On December 3rd, it's an open lab, so you can work on the term project. If you have any questions, you want to show something, make sure you're wrapping things up with the project. The document, don't forget, you have to have a report of the documentation. I gave you that template to follow. We talked about it. You have that templates for the testing. You have to have those templates plus, your demo of your code working. Presentations are going to be December 8th, a week from today. You'll do your slides, your demo, and show your report. Make sure you have your report with you and that you show the testing templates, the documentation, etc. If this project will presentations might take a while, so we'll definitely need both days, but I'd like to get as many students as possible to go on this day, so that, because the last day will be, of course, December 10th for the presentations. All right, and then don't forget, we have our just letting more people in. We have our final exam. Okay, so we can check that. So we can go to Google and then PNW final exam schedule. All right, so you should be seeing PNW final exam schedule. So as you can see, we have our class meets Tuesdays and Thursdays at 6. All right, so here it is. So that means your exam is on Tuesday from 7:15 to 9:15 p.m. Okay, so don't forget that. All right, so exam is on Tuesday. Starts at 7:15. It'll be similar to all the other exams. Written exam, it's comprehensive, so it'll cover everything, every topic from the beginning of the semester until pretty much the presentations on the 8th. All right, so that's really the plan for the rest of the semester. Don't forget, you'll need to submit all these materials. I will open a Dropbox around this date so that you can start submitting. Everything is due by the day of the final. That would be the very last cutoff date when you can submit something. But the presentations need to happen in one of these 2 days. All right, so let's go back to the slides now. All right, so today, as I said, we've gone over all the topics at this point in the semester of our course, Software Assurance. So we've covered everything that we had time to cover. And now today, I'm just going to do a short summary of some final recommendations. So this falls under the idea of recommended best practices. So I have a set of slides that we can use for this. And so basically it's going to be recommended practices of software assurance. So this, so there's a document that we can use. Okay. All right, so I think now I'm going to share the document. Yeah. All right, great. So, so this is a document from the Software Engineering Institute. this is a document from the Software Engineering Institute, and it basically just provides some recommended practices for secure coding. Basically, it was written for C, C++, but a lot of this really does apply to a lot of, it will apply to a lot of other programming languages, so it doesn't necessarily just have to be C and C++. Right, so basically, I'll talk about certain concepts, and a lot of this we've talked about already. So as I said, this is just really a summary of everything. So, it talks about recommended practices, secure software development principles, right? So I can't write on this, but at least I think you can see the cursor. So systems quality requirements engineering, so quality engineering, right? Threat modeling, use and misuse cases, right? Architecture and design, off-the-shelf software, input validation, data sanitization, static analysis, quality assurance. So a lot of these, just old concepts here, old topics related to the goal of providing reliability to software assurance. So if you think about this, I set this at the very beginning of the semester, right? All fields of engineering, for instance, have engineering in particular have some kind of reliability of their systems, right? So mechanical engineers, there's reliability of the metals, etc. Civil engineering, there's reliability of the concrete, and so on. Industrial engineering, there's reliability of the processes, reliability of the manufacturing, the supply chain systems, right? Reliability of a system really doesn't have to be a physical system, but other fields, biomedical, reliability of medicines. So anything that you build, there's always that reliability built in. And if you remember at the beginning of the semester, we said that with software engineering, it's actually not. It's somehow that has been missing, right? That reliability has been missing of ensuring that the code is good, and we kind of motivated that humans make mistakes, so it's kind of difficult to make 100% free of error code, and that's fine. But the whole point of this is not to criticize software engineering, but just to think of this as, okay, if you're developing software, if you're working on some kind of software, you must think of reliability as part of it. And just like in other fields, it's very important. We've actually seen it's quite important, right? Because a lot of the times, like we saw those airplanes with the 737 MAX, right? They might be very well, the engines may have been really well engineered and reliable. The wings may have been very well engineered and reliable, but the system itself, the combination of what they did was not necessarily great. And so that's the idea that, software is important. And as you know, that's what this class was for, the software assurance, to ensure both quality and security of our systems. So this just kind of wraps that up. All right, so basically the recommended practices, you have really a life cycle, right? So the software development life cycle, you can see that here in red, basically provides the secure software development principles, security, defense, and depth. It's a life cycle, as you can see that, it goes, right? So you start with the requirements, system quality requirements, engineering, threat modeling, use cases, right? So this is, as far as your term project, in your documentation, right, you had a section for requirements of your system. The uses, misuses, so cases of how you use it and misuse, that's there. What are some of the threats? What are the reliability or quality requirements of your system. Architecture and design of the system, that's, getting into the flow charts, creating the databases, creating all the modules, the architecture and design, or maybe it's off-the-shelf software, either way, some kind of design. And then there's obviously, so you guys already have code that has been designed really. So that part was almost done. And then there's the implementation, which is the input validation, data sanitization, code audit, static analysis. So implementation is a lot of what you were doing this semester. But also, so that needs to be reflected in your site working, your e-commerce site working, but also the quality assurance, right? The quality assurance is really important. And, the testing of, you guys know that you need to do those types of testing that we discussed in a previous lecture. The testing and reviews. And then after that, post-deployment, any kind of permissions later or anything, just anything that you need to update about the system or continuous improvement, etc. And then it's a life cycle where you can come back to check the requirements again and so on. So it's a cycle that works like that. But in essence, this is the software development life cycle. So it follows these steps. At the end of the day, you can think of the term project as the project, the software project, and then your report kind of follows this. You've been following this whole semester. So if you think the threat modeling and everything, that's making sure a lot of those labs that we covered, that are there taken care of. Remember, I provided a list of about 30 questions. Make sure you go through those. Usually those cover a lot of the things. And you need to provide that questionnaire with answers, right? Now, I'm not asking for several paragraphs or even screenshots. Just 2-3 sentences that you've addressed it should be enough. All right. So secure software development principles. All right. So these are basically some ideas that whenever you're developing software that you want to incorporate into your program, right? So an open design in particular. So no obscurity of the code. It's always better if the code can be modified by multiple people. Defaults for fail safes, right? Things that, if something fails, there's something that you have ways of handling things, and usually you'll detect those things through testing. Separation, a lot of ideas like separation of privileges or the principle of least privilege, right? So these ideas apply to restricting access in the database, for instance, right? Where, we talked about this, like you need to create some accounts, and if an account does not need to have delete permission, then remove them, okay? And so on. So these are just some of the ideas that you can consider in your design. Certainly open design is a good one. We don't have to get into a lot of these, but certainly, there's some theories out there of things that can be considered as principles. All right, and then I'm not going to go into all of these. I mean, you can actually read through these ideas, but let's just take an example of one. So if we're doing secure software development and we're trying to follow these principles and we want to follow the principle of economy of mechanism, then that principle basically says security mechanisms should be small and simple so that they can be easily implemented and verified. Which makes sense, right? That kind of, so instead of convoluted. So complex designs increase the likelihood that errors will be made in their implementation, configuration, and use. And so again, this is not terribly, I mean, it's kind of intuitive that that's something that should apply, right? But these are just guiding principles to follow as you develop software later on in life, right? For whatever. Here, this project is web development. You have seen it, so this applies to that. The effort required to achieve an appropriate level of assurance increases as security mechanisms become more complex, and you know that. So it is better to spend more effort in the design of the system to achieve a simple solution to the problem. So that, you know, as I said, that's pretty obvious. But that's just an example of, again, if you're considering software development and you want to follow some principles, you know, these are some ideas to consider. Look at this one, fail-safe defaults. So it's basically access decisions should be based on permission rather than exclusion. So that just says only these people are permitted to do this, instead of this person is not allowed to do this. You know, so the idea between the difference between whitelisting and blacklisting. By default, access is denied, and the protection scheme identifies conditions under which access is permitted. So this is, you know, like firewalls work this way, right? So everything is blocked except then you add exceptions. All right, so that idea is clear. The next one is complete mediation. So the complete mediation principle requires that access to every object must be checked. So think about that. Access to every object must be checked. So the source of every request is positively identified and authorized to access a resource. So we've talked about this, right? With the, for instance, we've seen examples of that with databases. We've seen examples of that with web same origin policy. We've seen that actually with the race condition lab or vulnerability topic. So really it makes sense, you know, whenever a user is going to access a resource like in your system, it'd be great if you can trace who they are and, you know, run them through an access control list of some kind. And so we have seen some examples of that as well. So you implement this as much as possible. So that's why it kind of makes sense to create user accounts as well. And that's something that's a requirement in your e-commerce site, right? So the fact that you have user accounts basically means that you have a way of tracing everything done on the website and by what user, what transaction, who was the user, etc. Open design, a secure design should not depend on the ignorance of potential attackers or obscurity of code, right? So that's usually a very general description in everything. It's not security through obscurity. That way, code is open to inspection by more people, and more people are able to detect or improve the code. Okay, so that should be clear. Separation of privilege. Separation of privilege eliminates a single point of failure by requiring more than one condition to grant permission. So such as two-factor authentication schemes are example of this. All right, so here we're not going so much into this. So usually if you had the company and you guys have the fulfillment area in the admin section of in the inventory section of your e-commerce site. So there in the warehouse, usually the person that fulfills the order is not the same person that checks the accounting. So both of those have to be reconciled somehow, right? So there's some kind of separation of duties, but this we haven't really covered as much this semester. But it's just the idea of having not having a single point of failure. Right, so this just keeps talking about passwords. Okay, still talking about that. All right, least common mechanism. So mechanisms common to more than one user should be minimized because these mechanisms represent potential security risks. If an adversarial user manages to breach the security of one of these shared mechanisms, the attacker may be able to access or modify data from other users, possibly introducing malicious code into processes that depend on the resource. So designing systems so that the mechanism executes in the process space of a program and is not shared with other applications is should be good. Yeah, so that, you know, that basically like a buffer overflow type of an attack, right? If a lot of people are using that server, that certainly is a potential problem here. So you would want so designing systems so that the mechanism executes in the process space of a program and it's not shared, without, you know, having that limited in some way would be a recommended thing. Obviously, sometimes that's not possible. But that, again, that these are just philosophies of things to follow. So psychological acceptability. Many of the vulnerabilities in the US CERT vulnerability database can be attributed to usability problems. After buffer overflows, the second most common class of vulnerabilities is default configuration after installation is insecure. Okay, so as you guys know, you know, this actually reminds me that you guys configured the database, right? The MySQL database. Now, what this is saying is that you should ask yourself the question, did I use default parameters for everything? We probably, you know, we usually have a tendency to do that in the beginning, right? We're setting everything up and we just want to make sure it works. And so we don't exactly put in very secure passwords. We just accept all defaults in the given passwords. Well, this is the problem, right? That you kind of left that insecure there. Okay, I don't even understand this, Joe. All right, so but that's the idea. So, you know, default configuration, you know, so that's an example of the psychological acceptability. That's a philosophy. So other usability issues that cause vulnerabilities include programs are hard to configure safely, sure. Installation procedure creates vulnerability in other programs, okay. All right, maybe. Configuration problems, confusing error, and confirmation messages. So a lot of this just has to do with sysadmin, right? And you just kind of, to get through it and get it installed, you kind of leave it insecure. So I would say the best example of this idea of psychological acceptability is the fact that, you know, ask yourself the question. I'll ask you this question on the project demo. What password and user did you use for the MySQL configuration? Did you just use default values? Well, this is saying that that's not something you should do, right? So it's a reminder of that. Are there any questions so far, guys? Any questions, comments?
No.
Nope, making sense. All right. All right, so then, you know, we continue with our kind of review here. Now we're going to focus on systems quality requirements engineering, all right, which you guys have done for your project as well. So basically, I've said this before in the slides, when security requirements are not effectively defined, the resulting system cannot be effectively evaluated for success or failure. So this basically, remember that in your report that you have to present a week from today in the presentations, that report should have, now you don't have to have every single requirement in there. I'm really just looking for a few that you went through the exercise, really. So But really that document should reflect all the requirements that you have in there. So here in particular, security requirements are often missing in the requirements elicitation process. So this next paragraph, the return on investments, is just talking about profitability, and basically says that when security analysis and secure engineering practices are introduced early, you know, that's gonna improve your income. Yeah, and so there are some models for this, right? For systems quality requirements engineering, such as Square. So now this Square, or a system for quality requirements engineering process, has 9 steps, right? So you can see here. So we can take a look at them. So let's take a look at just to follow the process for analyzing security requirements. First, we can agree on definitions, then identify security goals, develop artifacts, perform a risk assessment, select elicitation technique, elicit security requirements, categorize requirements, prioritize requirements, and the requirements inspection. Okay, so again, these are just models. They're not law, or, you know, they're just recommendations. So what I would say with a lot of these is just read them, you know, kind of intuitively understand them, take the best of what you can find, right? So here the idea, agree on definitions. So obviously you want to agree on definitions, and that's a prerequisite to security requirements engineering. On a given project, team members, right? So team members tend to have definitions in their mind based on prior experience, but those definitions won't necessarily agree. So you really have to communicate well and get it in writing. So, and get everyone to sign off on things. But it's best not to invent definitions, and the sources will include standards, you know, documents, the guide to the software engineering body of knowledge. So just, you know, getting a lot of these, get help from documents, but basically it's a communication with team members, that everybody understands the project well. Then, of course, identifying security goals must be identified and prioritized for the organization and also for the information system to be developed. Different stakeholders have different goals, but the goals usually can relate to the principles of information assurance, confidentiality, integrity, availability, non-repudiation, authentication, and so on. Develop the artifacts. So a lack of documentation can lead to confusion and miscommunication. So basically in your term project right now, you need to have a report, right? You know that it's not just about showing up with the code. You need to have the report, and the report should, you know, consider a lot of these things. That should have the documentation well in there. Right, so it should have the documentation in there, you know, with all the information. So basically, you have a concept of the operations of the system. You want to succinctly stated project goals, documented normal usage and threat scenarios, misuse and use cases, and other documents needed to support requirements definition, you know, flow charts, etc. So any kind of information like that. You also need the testing template at the end, so don't forget that. Perform a risk assessment. So there are a number of risk assessment methods to select from based on the needs of the organization. The artifacts provide the input to the risk assessment, right? So now you have a document that talks about the project, the software, And so you can literally then take a look at everything really about it, right? It's all there in writing. And then the outcomes of the risk assessment can help to identify high priority security exposures, issues, etc. Select elicitation technique. Selecting an elicitation technique becomes important when there are several classes of stakeholders. A more formal elicitation technique, such as structured interviews, right, can be effective when there are stakeholders with different cultural backgrounds. You have, people who don't know anything about technology, right? You still have to communicate to them about the system, whereas you have people with a lot of technical background, like you guys, right? And so, it might be very easy for you to understand the system, but it might be not so easy for your grandma to understand the system. In other cases, elicitation may simply consist of sitting down with a primary stakeholder to try to understand their security requirements. Right? So really, I would say there are requirements both of the functionality, but also, what their assets are that they want to protect. Okay, so we talked about elicitation technique, then elicit security requirements. In this step, the selector requirements elicitation technique is applied, basically, and this provides detailed guidance on how to perform, or you should have enough guidance on how to perform the elicitation. Once you have the requirements, you probably want to categorize them. So categorization allows the requirements engineer to distinguish between what are goals of the project, essential requirements, architectural constraints, right? So again, with your term project, your e-commerce site, what is the goal of it? Sell products, make money for your company securely, and protect the information of your users. So you'll have some essential requirements that you need to have in there. The system is pretty much already done, but just identify them and document them in your report. And then what are the constraints? You'll have to think about that. Well, one of the constraints is obviously the internet, authorized.net, that's your clearing provider, so you're dependent on that. If that doesn't work, you have a backup plan, and so on. Prioritize requirements, that makes sense. Prioritization may benefit from a cost-benefit analysis to determine which security requirements have a high payoff relative to their cost. So it's all financial. Even right now, as you're doing things, as time is approaching to your presentations, you have limited resources, right? So you have to make decisions of what you can still do because, it's worth points and so on. And the last one, the requirements inspection. So here, for instance, inspection can be performed at varying levels of formality. We don't have to worry about Fagan inspections or anything like that. But once inspection is complete, the organization should have an initial set of prioritized requirements, and then in this security requirements. All right. Threat modeling, right? So basically, we've spent a lot of time this semester talking about this, right? For the security of your system. So to create secure software, it is necessary to anticipate the threats to which the software will be subjected. So, the best thing that we can do is expose you guys to a lot of things, right? So a lot of not really specific attacks, but mostly like classes of attacks, right? So this semester we've looked at a lot of injection attacks, buffer overflow type things in C language versus SQL injections and web applications and so on. So you basically at least now have a certain sense of some of the threats out there. So understanding these threats allow resources to be allocated appropriately, so you have a better sense of how, how to protect against all of these things. Threat models consist of a definition of the architecture of the application and a list of threats for the application scenario. Okay. Now the threat models should be reviewed as the requirements and design of the software evolve. So obviously, that's why we started with, it's a life cycle, so the system development life cycle. And so in a life cycle, you're going to constantly review things as they evolve. Inaccurate models can lead to inadequate levels of effort to secure the system under development. And companies like Microsoft and other companies, they have defined approaches, structured approaches for all these kinds of things. So we don't, you can just read through this one. Microsoft's threat modeling process consists of 6 steps. Identify the assets, obviously. Usually everything starts with that, if you notice. Identify the assets that a system must protect, create an architecture overview, document the architecture of the application, including subsystems, trust boundaries, and the data flow. Decompose the application, the architecture of the application, including the underlying network and host infrastructure design, the OS, right? So for you guys, your Linux environment, create a security profile of the application. So don't forget, the sysadmin, patching and system updates and all that. The aim of the security profile is to uncover vulnerabilities in the design, implementation, or deployment configuration of your application. Then, of course, you identify threats that could affect the application, considering the goals of an attacker and the architecture and potential vulnerabilities. So if you're using Windows, you're going to have certain environment. If you're using Linux, you have another environment. If it's a phone, it's a different environment. So you need to consider those things. And then to conclude with the Microsoft threat modeling process, you document the threats. So document each threat using a template that defines a common set of attributes to capture for each threat. And you rate the threats. So this is very similar to a risk. Microsoft's model is very similar to just standard risk and control matrix, really. The last step, you prioritize the threats that present the biggest risk based on the probability of an attack and the resulting damage. And some threats may not warrant any action based on comparing the risk posed by a threat with the resulting mitigation cost. And so a lot of this should be very familiar to you. We've covered a lot of this actually in 350 when you took that course. So that's there. The output from a threat modeling process can be used by project team members to understand how to address the threats and the threats that need to be addressed. So you should do this for your project, kind of do this, what are the threats to my e-commerce site, right? So think about, so first identify what are the assets that you're trying to protect in the e-commerce site. Then threats, code injections are threats. We've seen a lot of labs on those. How does buffer overflow fit into your overall? So let me ask you this question, actually. This is a question I'm going to pose to you. It's a very nice exam type question. So let's say I ask you the following. For your project, your e-commerce project, what area, first of all, do the web security types of attacks that we saw, do they apply to your project, and if so, where? And the same next question is kind of similar. Do the buffer overflow attacks that we saw in class, do they apply to your e-commerce project, and if so, how? So if I asked you this question on the exam, what would you guys say? How would you answer that question?
So would it be like, since we have a database in which we're storing a lot of clients' information, we would have to guard that because of if anybody has access to like the database, they can overwrite information
How
for
can they
those
overwrite
clients.
information and gain access to the database?
I'm sorry?
How could they gain access to the database and steal or overwrite information?
Like
which
the SQL injection.
okay, the SQL injection. So then to question one, your answer would be yes, that it
Yes.
does. Okay, the web security supply, and you just told me how. What about for the, so that's correct. What about for the second question where I asked, what about the buffer overflow type? So all those that we looked at in the beginning, right? Set UID, all of that. Do those types of attacks in any way apply to your term project? And if so, how?
So for the second question, it would be yes as well because
Why?
like if anybody overwrites any kind of information that's already on some of the variables, they could maybe gain access or maybe steal information.
Right, but think about the nature of a buffer overflow attack. So would that type of an attack be a threat to your term project? You're developing a web application, correct?
Correct.
How is that buffer overflow attack a threat to your e-commerce project?
Mm. Could something be overwritten that that we have on
Where
the?
would it be overwritten? That's what I'm getting at. Where?
Okay.
Because everything's about overwriting, right? But where?
Yes.
Where would it be overwriting?
What they would have, I mean, the attacker would have to know, like maybe an insider person that knows how the code works
Okay.
could overwrite something on I don't know the actual code to
Buffer overflow
damage.
attacks usually attack the operating system's memory directly, right? Like the stack.
Mm-hmm. Mm-hmm.
Mm-hmm. So how does that apply to your project? That's kind of what I'm getting at. Give me an example of where that attack could still, I mean, would they, so I guess my question is, would they, you know, remember the shell code, right? Would
Yes.
they inject the shell code into a text box in the web form?
Mm.
Or let me maybe give you more information. Maybe make it an A and B kind of thing. So A, you know, it affects the, you know, somebody takes the shell code and injects it into a text box in the forms of the website. B, somebody takes shell code and tries to attack the Apache daemon itself. C, somebody looks at your libcurl library in the server or the email and tries to attack that and inject that code into that daemon in the operating system. So which one of those three would you say is most likely to be the way that somebody would try to exploit a buffer overflow for your project? What would you say about that?
Oh, goodness. I think it would be C.
C, okay, why? Just tell me why.
Like if they wanted to gain access to someone that's like a client in our
They
database.
sell, right? They want to get a terminal, right?
Mm-hmm.
That's what they want to do.
Mm-hmm.
So, okay, go ahead.
I'm just trying to think.
No, you're right. I mean, but this is what I'm trying to push you guys into seeing the light. You know what I mean? It's that both the buffer overflow attacks that we saw at the beginning of the semester and then the web security attacks that we saw later, both apply to your term project. Because remember that your term project is not just the code in PHP or JavaScript, right? It is also the operating system itself. You guys are installing the HTTPS. You have to make sure you have the libcurl library. You're going to have to need an email daemon, right? You see what I'm saying? Apache runs the whole thing, correct?
Correct.
You know what Apache is, right? So it's the daemon for the web server, right? That's running in Linux. So all of those processes that are running in the background in Linux, what do they have to communicate? How do they communicate? They have port numbers. Remember that? Port numbers? That's how you communicate. What is the port number of HTTPS?
443.
There you go. Perfect. So therefore, that receives data that goes into a C program that was used to code, let's say, Apache, and there you have a potential vulnerability if that wasn't done securely. Do you understand?
Mm-hmm.
So the whole range of attacks that we saw applies to your term project. It's just that the web security ones more directly apply to, let's say, the text boxes in the website, whereas the more buffer overflow types still apply, but they apply more to the supporting daemons or programs like Apache, et cetera, that support the website, the email program, and so on. Got it?
Yep. Okay.
Any questions about that, guys? Did you understand? That's probably an exam type question. So make sure you sort of get that, right? So how do the labs really tie to the project, I guess? So that's why, although it seems trivial, one recommendation would be to simply to update your OS. The other one is to, or make sure you have updates, right? I don't mean upgrade, I mean updates. And then the other one would be to turn off any services that you don't need, because if there's a service out there, so imagine we did shell shock lecture, right, a week ago. So I could ask you, for instance, how in 2013 would you have had a shell shock vulnerability in your term project? If so, could that have been a problem? What would be your answer? So you have to go back to shell shock and what it means, right? We talked about it last week. Make sure you look at that video if you haven't done so already. But if you remember, shell shock, that was discovered in 2014. It was a vulnerability in Bash itself, which you guys know what Bash is because we've been using it all semester. And so Bash basically, from a web type of application, you could overwrite, you can insert basically commands into Bash and execute them. And that was not good. Do you see that? So that could jeopardize your entire e-commerce site. All right, so hopefully that makes sense. And that's what this is getting at, that when you do the threat modeling and you identify all of this, you identify what assets you're trying to protect, credit card information, your reputation, server itself, and then what are the threats? Pretty much every lab that we've seen this semester and how it ties to either at the low level, high level, and the controls, right? What are the controls? The shell shock, for instance, don't use a server that hasn't been updated since 2013. That's the recommendation. Definitely have a more updated. Did that make sense?
Yeah.
Thanks. All right. So, as I said, today I'm just really summarizing the entire class, trying to put it into context within, within the summary, which I like. This summary is pretty good. It allows me to tie a lot of things together. All right, so let's keep going. Use and misuse cases, right? So the security misuse case is used to describe a scenario from the point of view of the attacker, right? So you guys, done enough labs, I think, that you're familiar with a lot of these types of things. Misuse cases are effective in documenting intruder usage scenarios and in identifying security requirements. Misuse cases can be an effective tool in communicating possible threats to a customer or end user of a system, right? So that might be the thing that you show to your customers that needs to be addressed. That way they can make informed decisions regarding cost and quality. Obviously, that might need for you guys to put in more effort in your, analysis. Input validation, I would hope very, very strongly at this point, I don't have to say much about input validation, given that pretty much the solution to everything this semester was validate your inputs. So in your e-commerce site, you have a lot of these. A lot of these are already built, except for your email that you're implementing, your own modules. So any text box, I really just, if you're doing the login, you have a user and a password. We did the lab already, SQL injection lab, so you know very well what I'm talking about, prepared statements, all of that. So input sources must be identified. Input sources include command line arguments, right? Network interfaces, port numbers, environmental variables. We talked a little bit about environmental variables as it related to shell shock, and user-controlled files, as you know. So basically specify and validate the data. Data from all untrusted sources must be fully specified and the data validated against the specifications. And basically the system implementation must be designed to handle any range or combination of valid data. So you're doing this with the testing, I assume. Now you don't have to test, as I said, every single range. Just have coverage, although it's not very in-depth. Make sure you cover as much as possible and document it, please. So valid data is data that is anticipated by the design of the system that will not result in the system entering into an indeterminate state. So a system accepts two integers as input and multiplies the two values. So the system must either validate the input to ensure that an overflow or other exceptional condition cannot occur as a result, be prepared to handle the result of the operation. So we talked about this in particular when we talked about integer security. If you remember, I went over some cases there. So yeah, anything that leads to unexpected behavior is it's an issue. Input specifications, to validate input specifications for what is valid input must be developed. The specifications must address limits, minimums, and maximums, maximum and minimum lengths, valid content, what's allowed, what's not, initialization and reinitialization requirements, and of course, encryption requirements for storage and transmission. You guys in the project are dealing with HTTPS, right? Because it's an e-commerce site. So remember, this is easier than you think, but it's only a sysadmin thing. You put your system administrator hat and configure the server to support HTTPS. We covered this in 350, all the theory behind encryption. So, all of that should be very familiar to SSL, TLS. All right. Validate data against specification. Ensure that all inputs meet specification. Use data encapsulation to define and encapsulate an input. Input should be validated as soon as possible. Reporting the error as soon as possible often helps correct the problem. When an exception occurs deep in the code, it is not always apparent that this exception was caused by an invalid input and which input was out of bounds, right? So certainly you guys know this really well. So the specification of your system can be helpful for this. Some code analysis examples here. All right, so I'm not going to cover any of this. Pen testing. This is another concept. As you guys have done this in other classes, I believe. There's actually going to be a new class just on this. So pen testing in our programming. So pen testing implies probing an application, system, or network from the perspective of an attacker, searching for potential vulnerabilities. So certainly in 250, you cover like Metasploit and that kind of thing. What was the name of that? Kali Linux. So that, that's kind of a similar idea. So pen testing gives a good understanding of fielded software in its real environment. Testing includes scanning of common vulnerabilities. So you basically have tools that you can just launch to search for specific things. And then you have test cases can be derived from threat models, attack patterns, abuse cases, and so on. Right, so this is something you don't have to implement in the project. You have plenty to do. But certainly, as you test it, in particular the servers and the applications, you'd probably want to do some of this as well. So really, as it relates to your project, you'd probably want to do pen testing on the server itself. Look at all open ports, and that would give you some information. Fuzz testing, you're sort of doing this, but manually. There's actually automated ways of doing this, but basically it means it's a method of finding software security holes by feeding purposely invalid and ill-formed data as input to program interfaces, right? And it's really just to find quality issues, not so much, you're not crafting this, like a SQL injection or a cross-site script or anything like that. But it would require a lot of volume testing. And I would say it's mainly for finding problems related to reliability, quality, and so on. All right. So that's just another idea there. Code audits. As you know, you guys basically are doing code audits. A lot of the code was written, so you didn't really have to write it much from scratch. So really, source code should be audited for security flaws and vulnerabilities. You identify all points in the source code where the program accepts user input from an untrusted source and ensure that these inputs are properly validated. Any C library functions that are highly susceptible to security flaws should be carefully scrutinized. So you're not using any C code, but you know that obviously something to look at. Your code was web, PHP, and so on. Here, code audits should be performed on security critical components such as identification and authorization systems. So as this relates to your project, the thing I would say that's the most related is your login. And that's why I intentionally leave the login not done. So you actually have to create the login, but then with the SQL injection lab again, you've seen that you can actually bypass authorization, right? So you definitely don't want that. You don't want people logging into your system, pretending to be an administrator, buying all these products, changing prices, etc. Okay, so the login certainly applies to that. Developer guidelines and checklists. Checklist-based design and code inspections can be performed to ensure that designs and implementations are free from known problems. Checklists serve as a reminder of things that are already known. To document what problems the designer code has been inspected for and when these inspections took place, and as a means of communicating problems between developers, right? So, you basically create a checklist, similar to the templates that you're creating for testing. And I've given you, as I said, that list of questions that I want you to address. Now, you can also have an independent security review where you have external reviewers, right? You hire a team. Obviously, that's outside of the scope of what we're doing, but that's certainly a possibility. Now, kind of some final thoughts here. So can we test our way to security? Automated detection of guidelines is language, compiler, and operating system specific. Automated tools will generate false positives. So basically, any automated tools basically that you can create are not going to be the best. Automatic detection tools generate false negatives, failing to identify some code. So what this is saying is, can we test our way to security if we had, let's say, the automated tools? Well, no, because it's a difficult problem that automation cannot yet solve. Although there's something called GPT-3. It's a new system developed by DeepMind, I think. And apparently this system has now learned how to code. So it can actually create programs automatically. So it's not too far away that they'll use GPT-3 for this, right? For actually checking code. If it can write code, why not check the code? I'm sure they're already working on it. But anyway, automation cannot do it. And if automation cannot do it, well, the implication is probably that a person would have a hard time doing that. I have to somehow put this. Okay, great. So this next slide, again, is the security development life cycle that that we've talked about. What's important here is not really all the details of it, but that it's a cycle, right? It's a cycle. So here, basically, you have the concept of it. You have the ideas of it. So you have the product development. Secure design is there. Then you do internal testing. So not only did you guys do the coding, but then you guys have done the testing part, right? And then after that, you do other kinds of testing for security revisions, right? Once it's in beta, so it's out there being sort of used, right? Not necessarily the final one, but it's out there now. And you have if you had any incidents, best practices and learning, and then it's a cycle, right? You can see there the arrows, right? This is just a life cycle for security itself, not for the whole project, okay? So what are the goals of the security development life cycle? So you want it to be secure by design, right? So you want a design that incorporates security not as an afterthought or after the fact kind of an issue. So it reduces the number of vulnerabilities, which reduces the number of security updates, which we all don't like updates. Wouldn't we love to live in a world with no Windows updates? But you can never remove all vulnerabilities, unfortunately. Secure by default, reduce the severity of the vulnerabilities missed, right? Focus on defenses and reduce exposure, and continuous improvement, right? So these are the goals that you want to follow. Okay? And so you have, as I said, hopefully in this class, you've seen the life cycle to follow with your software. Again, it just, using Microsoft as an example, you have kind of an ongoing process of training, then analyze requirements, risks, etc. Then design the threat model, right? Then implementation, specify tools, verify, the software, release it, right? The final security review, and then have, a possibility that if there's an incident, then you have a response, and then it feeds all back into the, it feeds all back into the life cycle, because this is called ongoing process improvement. This dates back to Deming and TQM, Total Quality Management, and his whole philosophy on process improvement, which, believe it or not, although it seems like very obvious, right? This is a philosophy that came around the 80s and took over a lot of companies and all these principles. Anyway, okay. So basically then, this is just an example, predict, prevent, protect. So vulnerability research, tool development, that's for prediction. Prevent, run tools to fix bugs, pen testing. And then protect, the least, principle of least privilege, again, user accounts, if in the SQL database, if the account does not need to delete, don't give it that account. And then some types of mitigations that could be in place. So these are things to consider in the security development life cycle. All right, we can skip that. We can skip this. You can read these jokes, but I just don't find them very funny, to be honest. All right, and then, oh, that's it. So anyway, I don't really want to go over the examples, but I really like these slides. I think they have a good good overview of the course in a general sense, tying everything together. All right, so that's basically all that I have for today. This is the, we went over recommended practices for secure coding, basically, as it relates to the term project in particular, right? And just tying everything together. All right, so that's pretty much it for the lecture today. So at this point, I'm going to go ahead and